and whiteboard. All right, I think we're up and running finally. So the first part of chapter 6 is factoring. I think some of you may or may not have done this before. So we're going to kind of go through some of the basic types of factoring. I'll show you multiple ways to factor. When you do the test, some of the problems are going to tell you a factor a certain way. Factor however you would like. I mean, the test is not going to know how you factored. It's just going to look for the answer. On the test, I typically just tell you to factor any way that you like. So it's whatever method that you prefer to factor. And we'll kind of go through those things together. So just a quick overview of the first 6 sections. And this, I believe, is in my OneNote. I'm confirming now. Yes, it's the last thing here. So I'm going to draw it out just real quick. So the first thing we'll always look for is the greatest common factor, which we're going to start on here in a minute. And then once after you find the greatest common factor, then ask yourself, how many terms does it have? If it has 2 terms, or 3 terms, or 4 terms. Now, remember, everything that separates a term is pluses or minuses, right? So if I have 3x squared plus 2x, right? That is considered 2 terms. Here's my first, and then here is my second, separated by the addition sign. So after you do the greatest common factor, ask yourself, how many terms do I have? And you literally just look at the polynomial and ask yourself. If it has 2 terms, the only thing you can do is difference of squares, right? Or, a little harder to write on the small thing than I thought, sum/diff of cubes. And again, this table is on the OneNote, so if my horrible handwriting is not working for you, right? So we got to learn how to do those still, but the only way you can do a 2-term problem is know if it's a difference of squares or some difference of cubes. So in my opinion, those are the hardest because you either know them or you don't. If you know them, then they become the easiest, but if you don't know them, then there's no way to solve the answer. You have to do those 2 things. 3 terms, we factor. All right, and I'm going to show you 3 different methods. Most of you are going to prefer the AC method. Sorry, but I will show you the different methods soon. And there is one special case, where'd my pen go here, called a perfect square. The good news, you don't have to have that one memorized because factoring always works if the polynomial is factorable. Perfect square is just a quick way to solve the problem, but factoring always works. And then 4 terms is grouping. If it's more than any of these terms, so if it's 5, 6, 7, 8 terms, then you can't factor. The only ones we're going to do is 2, 3, and 4s. And the only way you can do factoring the 4 terms is grouping. 2 terms are formulas. 3 terms is factoring methods, right? So that's kind of the table that will help guide you through any problem if you always have that access. Because if you know how many terms you have, then you can pick the right function that will help you, okay? Any questions yet? And of course, we haven't gone over everything. We're kind of just doing definitions right now, but. All right, remember, if you have the little hand up, I can't see because I'm on whiteboard, so you're actually going to just have to unmute and chime in if you have questions. All right, so let's see, how do I, oh, right there, new screen. So I didn't erase, so I can go back if we need to. So first thing we should cover is greatest common factor, right? And so to do greatest common factor, sorry, there we go, is almost like doing the distributive method backwards. So if we have, lost my pen again, ax plus AY equals AX plus Y, right? The distributive property we learned in the very first week was if I took my A and I distributed everything inside of the parentheses, I get this, right? And honestly, that's all factoring is. I like to look at factoring as kind of like playing Jeopardy. You're going to get the answer. I'm going to give you AX plus AY, and you have to come back with what did I multiply to get to this? That's why I like to call it Jeopardy. This is your answer, and this is what you multiplied. So you're kind of working backwards. And the whole point of it, we'll get to that into chapter 7, is solving quadratics equations, because when you're in a quadratic polynomial, it's very challenging to solve unless you factor it and then or simplify it. And so we're going to learn how to simplify before we learn how to solve. So chapter 6 is all expressions. There is no equal signs. Chapter 7, the only difference between 6 and 7 is 7 now has an equal sign, and now we can actually solve for x. So the whole point of this is this guy, before we distributed it, is called the greatest common factor. So before you factor, you always need to take out the greatest common factor. All right. This is a step that I still to this day skip sometimes. I'll look at a problem and I think I see the answer already, and I forget to check for the greatest common factor. The greatest common factor is the first step. Always do this first. Right? And so to have something be the greatest common factor, it has to be common throughout the entire polynomial. That's why it's called the greatest common factor. It has to be common throughout the whole thing. So if I have, in this expression, 5x minus 10y, right? And you don't have to actually answer, but think about it for a minute. I mean, you can if you want to. What is in common through this whole polynomial, right? So if I look at this for a sec, well, the first thing I look at is always the variables. Well, I have an x and I have a y, and they are not common, right? They're not the same letter. So I know it has nothing to do with my letters. But if I look at the numbers, there is a number that can go in both of those, and the number is 5. So if I pull out a 5 out of the first thing, I have an x. Keep the sign. If I pull out a 5 out of the 10, so 10 divided by 5 is 2, and then I keep the y, and therefore there's my answer, and my greatest common factor is the 5. So if I gave you this problem on a test and I said factor it, the only thing you can actually do is pull out a 5. There's nothing else you can do right now. But that would be the official answer. So the one thing the book does that I don't really care for, let me go to a new page. I don't want to erase in case people want it. Oops, that's not what I wanted to do. Close that. Say we have this problem again. And again, if I'm going too fast, please someone chime in and stop me. 5x minus 10y. So what the book tries to say is, hey, I see there's a 5 here, and I can see a 5 can go here. So it kind of does like this division problem. And then 5 divided by 5 is x, right? Because this becomes a 1, and we're lazy, we don't write our 1s. And then negative 10 divided by 5 is a negative 2, and you keep the y. And that's a good technique. However, a lot of people think that you just cancel out the 5. We didn't cancel the 5 out, we pulled it out. So this little division trick works well to figure out what goes inside the parentheses. But what you have to remind yourself is whatever you divided by has to go to the outside as your greatest common factor. So you're not getting rid of anything. You're not changing the expression. All you are doing is going through and moving things around. Because if I redistribute this whole problem, then I can see that I have not changed it, right? If I distribute the 5 through, then this becomes 5x minus 10y. I am back to where I started, so therefore I did not change the problem. Any questions on greatest common factor? I'm gonna shrink this down for just a minute to see if anyone has any questions before we move on. I'm doing a quick check to see if any new people have joined us for attendance purposes. All right, I don't see any hands, I don't see any questions, so we'll keep moving on then. So I'll go back to sharing my board, whiteboard. Oh, correct. Well, now I know when I do that, it deletes it, unfortunately. Great. So I won't do that again. The good news, these are in my notes. So what if we did have this problem? So we have 10cx squared minus 2cx, right? So we have to look at this problem and ask ourselves, what does it have in common, right? So I'll give everybody a second to kind of look at that and see if you can figure out what it has in common. See if you can solve it, and then I'll start working on it. And again, if you want to answer, you're more than allowed to. I mean, but you don't feel pressure to.
Can I ask a question?
You sure can.
What does the C mean?
It's just a letter.
Okay.
Yeah.
So it's like
it's just a variable. Yep. Yep. So I have a 10cx squared minus 2cx. So if you don't like C, you can write a Y. I think this one's actually in the book. That's why I used it. But when you look at this, right, what do you notice that they have in common?
You can take out a 2cx out of both, and then you'll be left with 5cx minus cx.
Well, you're close, Matt. So if I take out a 2cx, right, and I'll do the little division trick so we can see it. So Matt says I want to take this out. So if I divide this side by 2cx, 10 divided by 2 is 5, but what is c divided by c? Well, that's 1. So I don't have to write that because, again, 5 times 1 is still 5. I've already taken care of that. But x squared divided by x leaves me a x. And then if I divide this guy by 2cx, 2 divided by 2 is 1. C divided by c is 1. X divided by x is 1. However, in this case, I can't be a lazy mathematician. I have to put the 1 in there. So the final answer is 2cx. I'm trying to make my c look more like a c and less like a parenthesis. 5x minus 1. God damn, I'm having a hard time writing this pad. 1. And the reason we have to put a 1 there is if I redistribute this, I better get back to where I started. So 2cx times 5x is 10cx squared, and then 2cx times a negative 1 is a negative 2cx. So if I don't put that 1 there, I have nothing to multiply 2cx by, and therefore I don't get back to the original problem for which I started. So that's where you kind of have to be careful of when do I really have to write a 1 and where do I don't have to write a 1. Remember, we are not changing the problem. We're pulling out what is in common and then going to see what is left. Any questions on greatest common factor? All right. I'm not going to go back to our classroom this time because it wasted my whiteboard last time. So then, well, what if we don't have something that's the greatest common factor, right? So say we have this problem. A squared minus b squared, right? And we look at this, and this guy has an A, the other one has a B, and there is nothing in common. So with this problem, does not have a greatest common factor. So if I go to my little table, which unfortunately I erased because I closed my thing, but we have how many terms? Well, I have a guy here, and I have one here, separated by a subtraction sign, so I have 2 terms. This means I now have to know the formulas. And one of them we said was called a difference of squares. All right. Well, what does that mean? Well, difference means to subtract. And squares means I have a exponent of a 2 or a power of 2. So as you can see in my problem here, I have a difference and these are both squared. So this problem is a difference of squares. And the formula just says that this equals a minus b, a plus b. So it's a formula. But the unique thing about this formula, there is a pattern, right? So if I take a squared and I take a b squared and I take the square root of both sides, and the reason I'm doing a square root is because of the squares word. Well, what is the square root of a squared? Well, that is just a. And what is the square root of b squared? Well, that is just b. Remember, the square root basically cancels these guys. And then I keep the sign. Put it in parentheses. I rewrite it and just change the sign. That's what the formula tells you to do. So you can do two things. You can memorize the formula. Of course, the test is open book, so you don't have to have it memorized, but know the formula, or know that if I just take the square root of the function, the expression, then I can get my answer, right? So let's try this one with numbers. So create a new sheet. Say I have, I'll try to stay in black here, 4x to the 4th minus 9y squared. The first thing we have to ask ourselves always, greatest common factor. Is there a greatest common factor here? If we look at this, we see we have an x, we have a y. They're not the same variable or the same letter, therefore they have nothing in common. So then I look at my coefficients, my numbers. I have a 4 and I have a 9. Well, a 4 is an even number, a 9 is an odd. They don't have anything in common. So therefore, this problem does not have a greatest common factor. Then I go to my table. I have 1, 2 terms. So it has to be one of the 2 terms. Well, I look at it. This is a square, this is a square, or a factor of 2, right? And then I got to ask myself, are my coefficients square roots? So I always like to do the little trick. So basically, if I think something is a difference of squares, I just put a square root over each term. And then I do the square root. The square root of 4 is 2. The square root of x to the 4th is x squared. So the little trick here for variables is this. Square roots, which I didn't draw very good, has a little 2 here. We don't write it because we're lazy, but that's why it's called a square root. If I take the number that's on the outside and I take the number on the inside and I divide them, 4 divided by 2 is 2. 2 divided by 2 is 1. So if you don't understand how square roots work with variables, that little trick always works. So the square root of 4x to the 4th is 2x squared. Remember, I keep my sign. Square root of 9, 3. Do the little trick, 2 divided by 2 is 1, so this just becomes a y. So there's my first grouping. Now, according to the formula, I rewrite it again, just with a plus sign. And there is my answer of a difference of squares. Any questions?
Yes. If the problem was an addition problem, would the solution be both addition, or would it still be subtraction and addition?
It'd be non-factorable. There is no sum of squares. It does not work with a plus sign with addition. So if you get one, say like this, 4x to the 4th plus 9y squared, or that's a horrible 9. The answer is not factorable. There's nothing you can do. Now, there's other methods that we'll learn later on that will still help you solve this problem. But for now, the answer will be non-factorable because there is no problem with a plus sign. Any other questions? All right, I'm going to put a difference of squares. I'll let everybody know what is a difference of squares. Well, sort of. We got to do one other thing here. Give you a minute to work on it, and then we'll see how we're doing. So let me come up with one here. Thanks. All right, see if you can do anything with that. I'll give you about a minute or answer any questions people have, and then I will start walking through what I would do. Remember, we've only learned 2 things right now, so there's only 2 options, so that helps a little bit. So before we can do anything, we have to see if there is a GCF. Is there a greatest common factor for this problem? The answer is yes, because I have an 8 and I have 18. They are both even, so therefore I know I can bring out a 2. Right? So give myself a little room to work here. 8 divided by 2 is 4. Keep my sign. 18 divided by 2 is 9. So I know there's a 2. Then I look at my variables. The first term has an x. The second term does not, so can't do anything with the x. But I notice in my first term has a y, and my second term also has a y, so I can pull out a y. Well, y divided by y is just 1, so I got to bring down the x to the 4th, but no y. And then y to the 5th divided by y is y to the 4th. This is going back to our rules of exponents we learned very in the beginning. And now I've taken out the greatest common factor. So step 2, I look at my table. And I count how many terms I have. I have 1 term and I have 2 terms. So I look under 2 terms. I have sum of squares and sum of difference of cubes, which I haven't learned cubes yet, so pretty much limits our answer to squares problem. It is a difference problem. It is a subtraction. So then I do the little trick that I showed you a minute ago, and I put a square root over the first guy, square root over the second. Now we have to be careful here is don't lose this guy. We don't care about him really anymore as anything we have to do with him, but he is part of the answer. So I'm going to write him again because I don't want to lose him. I take the square root of 4x to the 4th, which becomes 2x squared. Remember, there's a little 2 out here. Bring down my sign. Square root of 9 again is 3, and this becomes 3y squared. And then according to the formula, I just rewrite the answer again with a plus. And then this whole thing is the final answer. Any questions on the 2 steps I did? All right. Let me check something real quick here before I go on. I want to make sure I'm not going too fast. I also don't want to go too slow, but I'm going to see how much I planned on covering today. Okay, yeah. So bring up a new page. Now let's go to our next term, two-term one. Sum slash difference, E-R-E-N-C-E, of cubes. Very similar as the one we just did, right? Hold on, fixing my OneNote. There we go. I have words on top of words. I just noticed. There we go. And this is actually 6.3. So I'm instead of following the book, I'm following the table. So sum of the difference of cubes formula is a cubed plus b cubed, not squared, cubed, right? So the formula says this is a plus b times a squared minus ab plus b squared. And if I do a difference of cubes, then it is a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. So there's the formulas. And what do we notice? Well, we notice whatever sign we start with stays in the first grouping, right? And then the sign changes in the second grouping, right? So that's kind of the formula. Now, how do we actually solve this problem? Well, just like what we did before with my little trick, if I, instead of taking the square root, I take the cube root, right? It will still work. So let's do an example here so we can kind of see it. X cubed plus 216. Wow, we always should look for a greatest common factor, but this first term only has an x. The second term is only a coefficient, a number, so therefore they have nothing in common, so no greatest common factor. There is two terms. Well, this is a cube, so it is not a squares problem, so therefore it has to be a cube problem. The more challenging part is this thing a perfect cube, right? Now, what you want to look for on your calculators is a key that has a little 3 here, or a key that has like a y and an x here, so that you can actually find the cube roots. Now, typically, I will stick to numbers that you would kind of know. So I'm going to jump up to a new page just for a minute, and then I'll come back to this problem. So I'm going to go back to black. 2 to the third power is 8. 3 to the third power is 27. 4th to the third power is 64. 5 to the third power is 125. 6 to the third power is 216. So those I've got memorized. You don't need to, because if you go to your calculator and you find this little key and you put in an 8, your calculator will spit back out a 2. So if you don't have the first couple of sets of cubes memorized, then definitely make sure you know how to use your cube root key. So let me go back to this problem. So if I do the cube root of the first term and the cube root of the second term, remember we can do this whole division trick. So 3 divided by 3 is 1, so this becomes an x. I just showed you on the next page that the cube root of 216 is 6. Remember, we keep the sign, so this becomes x plus 6. So to find my first grouping, I take the cube root of each term and I write their answer down. Now, how I learn the formula. I don't even care about where I started no more. So ignore that. Don't care about it. Only care about this guy. Okay? So if I only care about this guy, now I follow the formula. So notice there was an A here, and there is an A here. So this A and this A are the same, except for he has a squared. So what that's telling me to do is I take the first term and I square it. Then I change the sign. Then my next thing says here, A times B. So I take my first term and I multiply it by my second term. So x times 6 is 6x. Then notice there was a plus sign. And then my last thing has a B, So I square my last term. So 6 squared. Now, if you write this all out nice and neat with all my scratch over here, I get x plus 6, x squared minus 6x plus 36, and that is the final answer. So this one is the more confusing one to people until they get comfortable with the formula. What questions do you have, or just look at it for a second to see if you can follow the pattern here? All right, don't want to ask any questions. So one thing we notice here in my answer though, is I end up with a 3-term problem, right? And we said we can, for 3-term problems, we factor according to the table. We haven't learned factoring yet, but I still want to bring it up now because this term is not factorable. So don't try, it will not work, all right? No matter what, all the methods I teach you, that is not factorable. So even though it has 3 terms, you cannot factor it down anymore. That is your final answer. All right,
What
another one?
You have underlined in red. Is that 216 or is that 21?
The 216, you have to know because that is a number. There is no letter there, so you just have to know how to take the cube root of a number. Unless, like I said, you have those numbers memorized. Right, so I underlined the 216 because the 216 is the perfect cubed. It is the perfect cube of 6 cubed. So that's how, when I go back here, that's where this 6 came from, was taking the cube root of 216. Did that answer your question, Tim?
Yes.
Okay. Good. Yes, please ask questions because this is hard. Because one, I can kind of, when we're in the classroom, I can kind of look at your all's faces because some of you make unique faces when you're lost, and I know to slow down. Here, I'm just staring at my whiteboard, so I can't see you all. So I need you to kind of chime in. Just like when I keep pointing at numbers with my pen, that's why I'm underlining things, because I keep pointing at things on my keypad, and then I realize you can't see what I'm pointing at. So that's why I'm doing the underlining technique, to try to show you what specific number I'm talking about. And that's one reason I'm also recording this, so when we finish and you leave the class, you're like, that was insane. You can kind of go back and watch it and pause as you need to try to follow this again. So let's do another problem. Let's see here. 27x to the 6. We'll do a subtraction one. Minus 125 y to the 12th. All right. So first thing we always look for is greatest common factor, right? So I have an x, I have a y, so therefore they have nothing in common. Now you'll look at 27 and 125. Well, they're odd, so that means 2 and 4 and 6 and all that won't go into them. So then, well, I look at 3. Well, if you don't remember how to see if 3 goes into something, you add up the numbers. So 2 plus 7 is 9, and 3 goes into 9, so therefore 3 goes into 27. 1 plus 2 is 3 plus 5 is 8. 3 doesn't go into 8, so 3 can't go into it. So if 3 can't go into it, that means 9 also can't go into it. So 27 and 125. Oh, sorry about that. Hold on one second. Mute my phone. They have nothing in common. So there is no greatest common factor in this case. So step 2, I go to the table. Right? So I have 2 terms. So therefore, I now have to ask myself, is this a perfect square or a perfect cubed? Well, if I look at my exponents, they are even, which means I can take the square root of them. However, I can't take the square root of 27 and 125, because if you take the square root of 27, there is no 2 numbers that give you 27. So even though I can take the square root of the variables, 6 and 12, I cannot take the square root of the coefficients, 27, 125. So this is not a difference of squares. So then the only thing it can be is difference of cubes, or the whole thing is not factorable. So to know if this is a difference of cubes, I put a cube root symbol, and I put a, now, come on, and I put a cube root symbol, right? And then, so I can ask myself, I always check the variables first, because if a variable doesn't work, then I'm not even have to worry about the numbers. But remember the trick, I can take the number on the outside and put it on the inside, and 3 can go into 6, and 3 can go into 12. Therefore, my exponents are also perfect cubes. They're perfect squares, but they're also perfect cubes. So my variables are good. So now I got to do the numbers. Is there a cube root of 27? And if we go back to our page, we see there is. And there's my 125. So therefore, this is a difference of cubes. So the first thing I do, take the cube root of 27, which is 3. Take the cube root of x to the 6. Remember, we divide those, so 6 divided by 3 is 2, so that becomes a 3x squared. I keep the sign. Cube root of 125 is 5. The cube root of y to the 12th, we divide them, is y to the 4th. And therefore, I have my first grouping according to the formula. So now to find the second grouping, I apply the formula. And the formula said I square the first term, I change the sign, I multiply the 2 terms together, and then I square the last term. Now I need to simplify this still, but that's what the formula says to do. Square the first, multiply the 2 together, square the last, change sign. So I simplify this all out. I get 3x squared minus 5y to the 4th. 3x squared, remember this gets distributed to both, so this becomes 9x to the 4th plus 3 times 5 is 15, x squared, y to the 4th, square the last term, remember it gets distributed, put the number and to the power, becomes 25, y to the 8th. And that is my final answer. Whew. Any questions on sum or difference of cubes? The key is knowing how to manipulate formula. That's why I said in the beginning of this class that the 2 terms are the hardest, because you either understand how to use the formula or you don't. There is no real trick or technique or ways around it. You have to apply the formula. Now the formulas have a pattern, right? The whole squaring, multiplying, change the sign, so it helps. But it really does come down to knowing those horrible formulas for the sum and difference of cubes, and knowing that formula for the, no, that's not the page I have the formula on, that formula. the formula for difference of squares. All right, and I do have these formulas listed in my OneNote. All right. Any questions on greatest common factor and how to factor two-term problems? All right, we're going to skip over 3 terms for a minute. We're going to go to 4 terms. So 4 terms is grouping. So let me come up with a 4-term problem so you can kind of see, because there's not a lot to this problem. So now keep pulling an eraser with 4a to the x plus 4a to the y plus x plus y. All right. First thing we should always look for again is greatest common factor. Now, be careful here. There is an x and here is an x, but it is not common throughout the entire problem. So therefore, it is not a greatest common factor. Each term would have to have an x for this thing to be called a greatest common factor. Just like this guy has a 4, and this guy has a 4, but the other rest of the expression does not have a 4, so therefore the 4 is not a greatest common factor. So for this problem, there is no greatest common factor. So now I say, well, how many terms do I have? Well, I have 1 term, 2 terms, 3 terms, 4 terms, right? So there is 4 terms here. So just clean up my problem and I'll erase all my little underlines here. So we know it is a 4-term problem, and then we notice there is no greatest common factor. So this is how grouping works. You're going to group the first 2 terms together. You're going to group the second 2 terms, the second grouping of terms, or the last 2 terms together, however you want to call it, right? That's why it's called grouping. You're going to group. And now, instead of trying to solve the problem all at once, we are going to solve it in pieces. So if I look at just what I have highlighted and grouped in the red parentheses, is there something in common there? Right? So we're just looking at this guy. And we notice there is a 4 and there is a 4. So I can pull out a 4. There is also an A and an A. So I can pull out an A. Then I am left with x plus y. Then I go to my second grouping, right? And there's nothing to pull out, right? Because they have nothing in common. So I am going to pull out a 1 as a placeholder, right? Because I have to have something out here. So if there's nothing in common, pull out a 1. Now, if you notice, what's in parentheses is exactly the same. It has to be. All right. If it is not, you have either missed something or it's not factorable. Right? They must be identical. They can't be close. They have to be exactly the same. So therefore, these 2 are exactly the same. So I am just going to rewrite that. Now what I do is I take the stuff on the outside and I put them together. For a plus 1, I put those into parentheses, and that is my final answer. So how do we do grouping? Step 1, group in 2 terms, right? Group everything into 2 terms. Step 2, find the common factor per group. 3, combine common, way too many M's, common factor, and step 4, I ran out of room. Rewrite common factor. The reason this works, notice we went from a addition problem to a multiplication problem, right? That's why we can do this. I have grouped things together, so if I FOIL this, I will get back to where we started at the very beginning. I did not change the problem, I just moved it around. Any questions on the steps of grouping? All right, so let's do a grouping problem. 3, yeah. I know most of you don't like red, so let me get off red. 3xy minus 27x plus 2y minus 18. So, first I looked to see if there's anything common. Well, I see this last number here has no letters, so I don't even care about the variables. He has none, so they can't have nothing in common. Now I just look at the numbers. My last 2 numbers are even. My first 2 numbers are odd, therefore they have nothing in common. So again, there is no GCF. So then I count how many terms I am based on the table, right? Table. Well, the table says if I have 4 terms, 1, 2, 3, 4, then I must do grouping. So let's go through the steps of grouping. First thing, put parentheses around the first, put parentheses around the last, and then I can go through the steps. So if I look at the first grouping, what do they have in common? Well, I can take out a 3, and I can take out an x, which leaves me y minus 9. Then I go to the second grouping, and I see they're both even, so I take out a 2, and I have y minus 9. These 2 things are identical. I combine my common factors, I rewrite my common grouping, and there is my final answer. Now, sometimes you may have to rearrange things if it doesn't work at first, right? So this one we see does work, but let's just try to rearrange it to see if it changes our answer. So say, notice up here, these guys have y's. So I'm like, I want to put the guys with y's together because I know they have something in common. So 3x y plus 2y minus 27x minus 18, right? And the commutative property allows me to do this. I can move things around. This is why we had to learn our properties way back in the beginning. So I look at this, I'm like, all right, not too bad. I rearrange things, so now I just follow grouping again. I put parentheses around the first, put parentheses around the last. Oops. If you have a negative sign, my recommendation is you keep that inside the parentheses and then put a plus sign on the outside like this, because you don't want to miss something that's in common here. So I look at my first term. The only thing I can pull out of this first guy now is a y, and I am left with 3x plus 2. Here, I can take out a negative, what can I take out? Oh, a negative 9, there we go. 27 divided by 9 is 3x. 18 divided by 9 is a 2. Remember, I took out the negative, so these things all became positive. And notice, I have things that are the same. So I combine what's outside, running out of room. Y minus 9, 3x plus 2. I got the same answer. So it doesn't matter how you rearrange them, you're going to get the same answer. Sometimes, though, you may have to rearrange them because at first you might not notice anything in common. But once you rearrange them and put things together that have things in common, then it may work. So if grouping doesn't work the first try rearranging things at least once. It may work. If it typically doesn't work after you rearrange them, then it probably means it's non-factorable. Whew. How are we doing? We're going about an hour. Going to the syllabus, I wanted to get to 6.4. What is 6.4? Let me check there. Okay. No, fractions. All right. I don't think we're definitely not getting the 6.4 today. So 6.1 was greatest common factor and difference of squares. 6.3 was in grouping. 6.3 was the sum and difference of cubes. So the only thing we have left to kind of cover is factoring, right? So 3 terms. And then this is where I'm going to stop today. Even though the syllabus said we're going to get to 6.4, I think we're going to stop at 6.3 and we'll start 6.4 on Wednesday. If I have, let's see here, how do I do this? X plus A, and then X plus B, right? And I FOIL this, I get X squared plus X to the B plus A to the X plus AB, right? All I did was FOIL. We learned this, I think, earlier in the semester, right? First, outer, inner, last. So, we notice here, typically when we FOIL, we can combine them in all terms. But in this time, I have an A and a B and I can't. But if I rewrite this as X squared, and you notice these both have X's. So if I take out an X, I'm left with a B plus A equals a, not equals, sorry, plus AB. I made a mistake. I can't get myself back on track here. Plus AB, there we go. We have a kind of a pattern here, right? This first method is kind of the one method I use, and I call it the sum product. And the reason it's called a sum product is I have a summation in the middle of a product of multiplying these two things together, right? So this is kind of how this method works for factoring. Saying I have X squared minus 4X minus 12. That is an ugly 4. Let me clean him up. All right. So notice here, my last term is multiplying the sum of these two terms, right? So if I ask myself, what is a product of negative 12 that will sum to negative 4, right? So negative 12 factors are negative 1 and 12, and then a negative 6 and 2. And notice here that a negative 6 and a 2 give me a negative 4. So because I know these two things equal this, and I go to factor this, this becomes X, becomes an X minus 6 plus 2. And there's my answer. Most of you will not like this method, right? Unfortunately, this is how I was taught it years ago, so this is my preferred method. There is a new method, which I'll show you here in a minute, called the AC method, which I think most of you will like. But as some of you are good with your multiplication tables and your factors, this is a quick way to solve it. And it typically works really well when there is no number here, when the number is 1. When the number is not 1, it gets a little trickier. And that's why I think most of you will like what we call the AC method. But I want to show you all the different methods. There is a method called trial and error, which is basically I create every possible FOIL scenario, and then I refoil over and over again till I get the right answer. I don't show anyone how to do trial and error because it takes forever, but it is a method in the book, so it is kind of allowed. I am going to go right to the AC method, and I have it kind of written out on the OneNote so that you can kind of see everything. So this is the AC method. So say we have 3x squared plus 16x minus 12, right? So first, GCF. 3, 16, 12. 3 can go on to 12 but on to 16. No x in the last term, so no. So next is we go to our table, and therefore we have to see we have 3 terms, so the only option is factoring. And I'm going to try to write out the notes as good as I can here, but I have them typed on the OneNote so you can kind of see things, how they work. The reason this is called the AC method is if we rewrite out the quadratic expression, we have ax squared plus bx plus c. And there is my A, C, right? So step 1 is to multiply A, well, I'll keep everything the same size, A times C. So if I do step 1 here, I take my 3, and I'm going to multiply it by negative 12. So 3 times negative 12 is a negative 36. Then step 2, factor, not sep, step 1. So what are my factors of negative 36? And this is where the AC method gets tricky because the numbers get big real quick, and I don't worry about the sign right now. I'm just going to write out the factors. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6, right? And now I've repeated numbers so I know those are all the factors of 36. So step 3, find factors that sum to b. And so remember, the b is the middle term. So I got to ask myself for step 3, which of these numbers give me a positive 16? Because that's where b is. So remember, this is negative, so I'm actually not adding here, I'm subtracting. So if I have negative 2 and a positive 18, negative 2 times a positive 18 is negative 36. Negative 2 plus 18 is 16. So I like to circle the one that works. And there is my step 3. All right, I'm gonna have to go to a new page because I'm running out of room. So step 4. And I'm doing this example I'm doing is in the OneNote, so you can kind of see it typed all out. Rewrite expression comma. Replace B with factors. So just so I'll rewrite this again. So our step 3, so we can see it again, had a negative 2 plus 18 equals 16. Right, so now I rewrite the expression. So I write 3x squared But instead of writing the plus 16x, I rewrite it with my factors. So I write minus 2x plus 18x, right? Because if I combine the middle terms, I get back to my 16x, but don't do that. Minus 12. So this was step 4 right here. I rewrote everything. Now, step 5, grouping. I have 4 terms. So the whole point of the AC method is to take a 3-term problem and make it 4 terms, and therefore I can now do grouping. So now I go back to the rules of grouping. I group the first 2, group the last 2, pull out what is in common. So the first one has an x, so I have a 3x minus 2. The next one is, what am I missing here? Oh, 6, there we go. So I pull out a plus 6, and that gives me 3x minus 2. Notice these 2 things are the same. So I combine my outer terms, x plus 6, 3x minus 2. And there is my final answer. So all of this right here was step 5. So it's a 5-step process to do the AC method. But if you can walk through the steps, it works. The good news with the AC method. Go back to the screen. No, not right, wrong place. If I can't find any factors from step 1 that sum to my B value, then it's not factorable. So I'm not going to be able to go through the whole problem to see that it fails. It will fail on steps 2 and 3. If I cannot find a factor that will give me my middle term, and I've listed all my factors, then the problem is non-factorable. We are going to have problems that are non-factorable, right? So, and that's where we get into chapter 7 of how do we solve problems that are non-factorable. Chapter 6, though, they'll be kind of factorable. But in the homeworks, they'll probably give you 1 or 2 that may not be factorable just to make sure that you're following the methods. So the good news is the AC method will fail on step 2 and 3 for a problem that is non-factorable. Any questions?